Okay, the last IoT protocol we are going to talk is COAP. COAP stands for Constraint Application Protocol. Like a DSS, you might need a little bit big, more powerful hardware configuration to run DDS. However, for very small devices like Arduino or like ESP8266, they are small and they do not have enough memory to run big programs. And COAP is very very short or small footprints. They can put on maybe all kinds of IoT end devices. And this is very good application because they mimic web service like a web server, but add event driven on top of the application. So not just web service, like you use RESTful to do the request and response, but you also can have event driven. When the device have something happens, they can tell you immediately, something like this. So COAP stand for, as I mentioned, Constraint Application Protocol. And you can say COAP is called an A and P here, COAP protocol. And it is defined by Internet Engineering Task Force. And that is for IoT and also machine-to-machine communications. The idea here is we want to connecting constrained devices to the internet, and based on the RESTful architecture or framework, and you can say that this is kinds of web service. And the goal is these end devices or IoT end devices can provide service to others. Actually, it is a server, so we will call it just COAP server. As this figure denoted, we have some kind of clients, and the client can send like HTTP request using RESTful way that you can get some information from the server. So you say get temperature, and then the COAP server will respond. The code is similar to HTTP protocol, but the whole package are more complex than this one. We will talk about this later. So you can get the temperature right now is 22.5 degrees. So why not just use HTTP? And you need to invent something new. If we look into the HTTP, usually they based on TCP/IP. To do the TCP/IP, you need to have three-way handshaking. And then maybe you want to get some information, and then you terminate, because maybe I would use this maybe 10 hours later, okay, and there's no need to keep connecting to the server. So in certain application, you might, for example, you want to read the meter of your water usage, or maybe any kind of utility. Maybe you want to read the information only once a month. So in this kind of application, HTTP, you always connect it. Or maybe we can see that you need to do three-way handshaking, and then a lot of package, and the package size are huge compared to COAP's package. And then you can say that maybe you send more than thousands of bytes information on the internet, and only you get is 2 bytes. So the overhead is too heavy. And suppose you have billions, as we mentioned that there will be 50 billion IoT devices on the world on 2020. And billion devices is huge, right? And maybe at the long run, you are not able to send any message out because the network congestion. So the problem here is the HTTP too many package. You just want to get the light or get the temperature. However, you have to do the three-way handshaking, and then really get the information, and then turn it off. So too many packages actually are transmit between client and server. The second problem is HTTP. They are using maybe more like powerful devices. So each package size is quite huge. So maybe at least when you send management package, it contains around 200 bytes, something like that. So actually, you can see that it's quite inefficiency if you try to use HTTP protocol. And the third thing, actually, they are not event driven. We definitely want to, if this guy, happens something, they want to notify the client sometimes. But HTTP, you have to keep connecting. The client have to keep polling the server. Do you have anything to do? Or maybe nothing to do. They respond to nothing. And later, HTTP client have to send another request. Do you have something? Is there anything happens in your side? And they say no, and well, they do nothing at all. So it's not efficiency at all. So that's why the smart people came out with this protocol called Constraint Application Protocol, and it is request response. So you can see that a COAP actually based on UDP, and they have a data transport layer security to make sure the information actually are encrypted in the internet. So there are two layers. The top layer is called request response sublayer. It's just something like web service. You send a request, and the server send a response, and they use RESTful way. So what I mean RESTful way, use get, put, and post, and delete. These 4 commands to do the request and response. So the interaction between COAP client and server are much reduced. There is no some like body, some like content. In HTTP protocol, they maybe have thousands of commands, but here RESTful only supports 4. It's just like create, and create, and read, update, and delete. So similar to database operations. The second layer is called message sublayer. The message sublayer actually provide more reliability transmissions, the packet transmission for you. So they can have, usually UDP, they don't have reliable transmission, right? They try to send and they will not resend, something like that. However, based on this message sublayer, it can mimic the TCP. If I send a request, and if the request need to confirm, if the message, the confirm message or acknowledge message did not arrive, I will resend the request again. Okay. So as I mentioned that COAP use RESTful interaction, and the RESTful has post. Post means I want the server when the server is power on, and he have to advertise himself to maybe gateway. So here COAP client is kinds of gateway. All these end devices, they want to export themselves to the gateway. Okay. So there are 2 ways to do it. One way is the COAP server or the end devices. When they power on, and they post its resources, or we call data model, to the COAP client immediately. And also tell the COAP or gateway, tell the gateway, what am I? Maybe I'm a coffee machine, and what kinds of functionality you can operate with me, something like that. The second way to do it in COAP is the COAP client or the gateway can issue a well-known code. This is why it's called well-known code. Well, it's just protocol. If you have a command like this, it does not belong to post, get, put, delete. However, if you put something like that, and it's kinds of requests to ask the COAP server, who are you, and what resource you have, and tell me these information, something like that. So in our implementation, we actually use this one. And when you try to do the COAP test, there might be sometimes you might want to, send requests to the COAP server and see if it's response back. Okay, and after the client or maybe just gateway and COAP server connect together, then the gateway can actually issue requests. And there are two kinds of requests. One is read and the other is write. Okay, so read information mean please tell me the temperature, the temperature of your place, something like that. So we can read some kinds of temperature. We use get, and this is the COAP protocol, and this is IP address, and go through the UDP port 5683. And this is what kinds of resources you want to retrieve from the COAP server. And here is the temperature. Okay. And you might want to update, like Jonathan can turn on the light, turn the light on, or maybe turn the fan on, and you can do something like that. You put, and this is the internet devices, and then you put the name, and maybe they have a couple of switches, and you switch something on or off. So in this way, you can send, turn something on, or maybe turn something off. And the last thing is maybe the COAP client doesn't like you. They want to just leave this gateway, so they can send this message to you. But this is seldom used. Only these three, and this is only do it once. Maybe when you power on, or maybe you disconnect and reconnect to the gateway, then you send who you are and what kinds of functionality. The message is up there. As I mentioned that HTTP protocol, the package is kinds of inefficiency. So how are we going to make it efficiency? We use binary encoding. So for example, maybe we don't need to see so many things. You can see that here we have have a code here. The code here actually, you can see that all the requests and response code actually implement in only 8 bits. So you can see that the code, the first 3 bit here, is denote the class, okay, and the the other 5 bits here denote the the items, or depend on the category. So we can see that if it is 0, the class, the 3 bit here, we have only 8, right, from 0 to 7. If it's encoded as 2, and it's kinds of a 0, and it means a request. So if I put a 000 here, and this is the request package. And if I put, and then if I get a request, and then I will have response, right? So 2 are successful response, 4 are client error, and 5 is server error. So you can see that these 8 bits can represent all the HTTP protocol from the request and response, something like that. So you have 200, right? What's 2 mean 200? 2 mean this is 2, 0, 1, 0. and 100 is 0, right? So all bit is 0. So you send a request, and if everything is fine, they will say 200 means successful. So you can see that 200 actually everything instead of 3 bytes, and you always use 1 byte to represent the whole request and response. And that is only for response code. But here we also encode a request here. So you can say everything is compact. The other thing you need to know probably is the message ID. When I send a request, and this request has a unique ID which called message ID, which is 16 bits. The other is token. It could have token or it may not have token. Token is the second ID you need to understand. So why is that? We will get into that. And then they have a marker. It's O1, they mean a marker. And finally, you have your payload, something like that. It's like a contents, right? Maybe we don't have to say, let's see the message sublayer. How are they client and server do the communication? First is no need to confirm, or maybe you just say it's unreliable transmission. That will be fine. So what?
What is the main difference between the message ID and the token?
Yeah, I would talk about this. Give you some example. So I say, well, if a client want to do some request to the server, so they will send a request. So this is the message ID, and NON mean no need to confirm. Okay. So basically, the type here, is the message type. This package actually is 0 mean it's reliable transmission. You send a request and you will wait for the response. Okay, and if you encode it as 1, this is 2-bit, right? Only 4 state. So if you encode as 1 and then you send a request, and it doesn't matter if the COAP server receive it or not. Okay, and if it's true, it means some kinds of acknowledgement. We will say why you need acknowledgement. And 3 is reset. So this is the type here. If 2 bits, and this is version. It doesn't matter. So here everything is fine, right? NON, you mean you send a 1 here. It's 2-bit. It's 0, 1. And this is message ID. Message ID actually just, in this case, actually they don't use at all. And since there is no need to confirm, when the COAP server may receive the message and processes this message, or may just never arrive, something like that. Okay, so we call this unreliable message transmission. So what is reliable transmission? Means something you need to confirm. It's just like all the TCP requests. When you request something, you definitely have to wait some kinds of response. And here we call it reliable message transmission. So here we send a confirm. I need confirm mean I need a response message back. So I get light from these end devices or IoT end devices, and when they receive this, I need to confirm this message. So I just piggyback the response. So you can see that the only thing you need to do is you don't need to regenerate another package. You just reuse the package you receive. Okay, and then you change from confirm to acknowledge. Remember, we say here, this is 2-bit, right? And if I send 0 from the COAP client to the COAP server, and then if you respond, the only thing you need to do is change to 2. That means this bit will be 1. Only change 1 bit. So I guess it's very efficiency, right? First, you don't need to regenerate a new objects, and you just piggyback. You just send this message back. And the second thing is they all feel already. Say message ID is already layered, so you can say here the same message ID. So this is the request, and this is response from this request. This guy might send a bunch of requests to the same COAP server, or maybe to different server. And the COAP client will keep keep some kinds of register, keep some kinds of table to indicate, do I get the acknowledge back, or do I get a response back? If not, then they will try to resend, and we would show this data. Okay, and this is the content. Okay, the content actually will be just put into the payload, and this is response code, right? 2.05. So so the payload will be put the content. So you put the end of this message, and then you also change the code here. The code here. In the beginning is request, so it's 0, right? It's all 0, okay. And what you get response back. First, you change 000 from 010. Again, only 1 bit need to change in this case. And also, you need to, they have 2 to the 5, 32 kinds of response message. And this is 5, 0, 01001, something like this. So they write the response call directly to this field and send it back. And also, the last thing is you need to piggyback you need to upload the contents in this payload field, so that you send back to the COAP client. So you can see that is very efficiency way. You don't need to generate a new objects. The second is you only update some bits, so that the information will be from request message and turn to a response message. So right now we are going to talk about the token and the message ID. So let's see in this situation. So sometimes if you receive a request, but the request might take a long time to measure, So actually you are not able to respond immediately. So in HTTP they weren't able to do so because everything have to wait, right? So you send a request and you keep waiting until it come out, right? But in the COAP, actually they deal with these kinds of situation gracefully. Basically, I use both message ID and token. So here we send a confirm message. So this means I need a response message back from the COAP server. So the COAP client send something need to confirm, and that is some kinds of request. Okay, and also they will associate with a token. So if the server decide this take too much time to do, so if I did not send back anything, then it will be typed out, and the COAP client would resend it. So you will be in a bad situation. The COAP client keeps send me this. Okay, so a lot of garbage will be flow in the internet. So the way to do it is because I know it takes too much time, so I try to acknowledge this message only. I haven't finished the job, but it doesn't matter. But I would tell the client that I got your request, but at the moment I can respond the result to you. So just send and acknowledge. So this the same message. Remember, it piggyback, right? So they just this message is responded by this package. So it's out, it's finished, it's complete. Okay, but this still unfinished because you haven't done the job yet, right? So the token actually indicates the real job actually haven't finished yet. So at sometimes if the COAP server actually finish the job, for example, they measure some important physical value, so that say in this case line is ready. So this guy actually issue a request package. Usually this guy request, right? In the HTTP, the only request have to come from the client, never from the server. But in this case, you can see that actually COAP server send a request to the client. So with his new message ID, and also with the token. The token mean, this message actually responds to your previous request. So the previous request is indicated by the token value here. And finally, you have the content here. Everything is fine, 205. And then these are the content you like to have, so that the COAP client receive the contents, and they also send the acknowledge back. So in this case, this is the acknowledge of this message, and this token actually acknowledge of the whole request. So it's kind of very, I guess it's very gracefully, right? I think so. So how about the resend? So I guess in UDP there is no resend at all, because maybe you want to broadcast something. Resend is costly, so they just, you lost 1 or 2 frames. Maybe the whole video, the quality of whole video won't affect at all. But for the data, one message is lost, then the whole thing is lost, something like this. So they provide some kinds of reliable transmission. So maybe you send a request to the server, and it was lost before the COAP server receive it. The other situation might be, the server actually got the request, but when the response actually lost when this message was traveling back to the COAP client. But both are fine. Let's see why it's fine. So in this situation, after the COAP client, when they send a confirm message out, they start a timer. If the time up, then they would send another request, because they haven't got anything back. So as I mentioned, there are 2 possible situations. One is the message actually, the request message does not arrive to the COAP server. The second case is they arrive the COAP server, but the response message actually lost, right? But it doesn't matter. If I send a request here, and then they will remember that the message ID this should be the same message ID, right? So indicate this is the same message, okay? And when you get back the acknowledge, then everything should be fine. And if maybe in some situation you might receive twice. So for example, maybe it's just a little bit late. Okay, maybe you set it here. You got at this point, you got the request, and you response in here, and you might receive twice, but it's fine because the same message ID. So you can just okay, I just use the second one because it's newer than the previous one, or you can choose the first one instead of the second one. So it doesn't matter. So I guess the COAP process the message loss gracefully as well. And they also provide some kinds of proxying and caching. The COAP try to connect not just COAP protocol. The HTTP protocol actually are quite easy to convert their requests to COAP requests. Okay, so here as example here, we have HTTP client here, and they send an HTTP request. And here we have a proxy. They understand the HTTP and also understand the COAP. So they will just this huge bytes, maybe 200 bytes, and they convert to maybe just 4 or maybe 5 bytes, something like that. So that this is 200 bytes, and this maybe just 5 or 6 bytes, something like that. Okay, so they kind of transfer to another COAP message. So when receive it, then they might tell the proxy that maximum age. This means freshness. The freshness value actually means that within 30 seconds, the value are unlikely change. So I mean, if it's still fresh, you don't need to ask me again, something like that. So they send back the contents here, and the proxy actually will cache the information. Before the cache the information, they actually send this this is light information back to the HTTP client by saying 200, and everything is fine, right? And they also caches, and maybe the same HTTP client or some other client actually send the same request to this COAP server. Since the data is still fresh, so there is no need to send out the request. So they just, since the cache is still fresh, so they can send back the data immediately without going to the COAP side, something like that. So this is proxying and caching. And these actually are described on the core spec. So there are two specs. One is COAP core, and what we say at the moment belong to the specification of core specification. The other specification COAP provide is called Observe specification. The Observe specification actually provide the event-driven request response service. So how can something like a web service provide the event-driven? Because I guess they facilitate this event-driven by using observer design pattern. So what do I mean observe pattern? If you write some software code, or maybe, do you ever write a Java GUI?
Java GUI?
GUI, like when I click a button, right?
Yes.
And I have to register some kinds of listener, right?
Yes.
Okay, similar to this one. So you can see that this was subject, okay, and this was observer, and you might have a bunch of observer. You can, in Java, you can think this is button, and this is one program, and they like to observe, the button state. The second observer, the third observer, they try to observe the button state, right? And so the first observer will register himself with a COAP function. So here there is no COAP function, but I mean in Java they register a COAP function. When the state change, please do this COAP function, right? So everybody can register their COAP function similarly. So this is called observe design pattern. So in COAP, the first is the observer can observe something from the subject. When they observe, they can also indicate, do I observe you, when you change state? I can say, if I do some registration, mean I'm interested in you. So if something changes, please let me know. Okay. So observer may say, okay, I just want to observe once, just like a request. So observe and will be some kind of piggyback with an normal request. So you might say, request, please give me the temperature, right? And if I put the observe flag as 0, that means I am interested in you. So if your state change, please let me know. Let me know means send a notification to me, or send the value to me, the change value to me. Okay. So in this case, I guess the whole scenario is you observe once, and with the you request once, but you set the observe flag as 0. The default is 1, and then you get the first response. And then if the value is changed, the subject will automatically send a request to notify something happens, and they will send back the acknowledge, something like that. So something changed, and it kind of event driven, right? Something happens, so I send the event to the observer, and then observer say, okay, I got it. And they might have a bunch of observers, as I mentioned. They try to observe you, and if your value is changed, they will send some kinds of event back to you. So similar to your security system, right? If something happen, actually you put some event on the broker, and you put some message to the broker, and all the observer or maybe the subscriber will receive it. So it's similar that kinds of function, but there's no broker inside between the observer and the subjects. So how do this work? So you can see that this is just a normal confirm message, and this is just similar to the get light. But here we have observe flag. Observe flag, actually we haven't talked about where is the observe flag. Actually it is in the, where is this? Wow, observe flag. Maybe some kinds of option. Okay, so in the option you can say observe flag actually is 0 instead of default 1, something like that. So okay, so here I send request, and this guy sent back a confirm message. Okay, but because I put observe here, 0 flag 0 here, and then mean, if you change value, please let me know, something like that. So you can see that if line change here, they will send an event or maybe send a request back to the client or the observer, and then this guy just send acknowledge back to back here. So here token play an important role. Okay, so that's why they need two kinds of ID. One ID is request response called message ID, and as you know that in the observe spec, they also need a token to denote that you respond to this guy, because they have some kinds of requests long time ago. So you keep doing this instead of just once, something like that. Because observe flag is 1. But observe flag actually is not quite finished yet. For example, it depends on your implementation. For example, one thing you can do is they check every second if the temperature or the value you want to measure difference. They send it back automatically, or maybe you can set 1 minute. So when 1 minute reach, and then you measure the previous one and the and the current value. If they are different, you send the request message, something like that. The other thing is you might say they have two kind of threshold. One is too hot, and the other is too cold. And between these two values, they are okay. But right now there is no way to specify something like this, because the COAP haven't complete this observe spec at the moment. So okay, enough talk. That's okay. You have
a question. On the COAP transmission, you got an acknowledge, and I think can you put back the picture 121, please?
121. Okay.
Yeah. Maybe before. Thank you. The one before. Yeah, this one. You acknowledge only the number with the number of the tram of the package you send. But how do you know that the content of the packet is okay? It's not because you did in some protocol communication, you've got some control, some control, like a CRC, to control the integrity of the package. But on here, like
CRC we're doing in the first layer. It doesn't matter, you know. If CRC is error, then the whole thing is the wrong message.
Yeah, but do you have a CRC?
No, there's no need. It's just, you know, a UDP, right?
Yeah, but like so you acknowledge like I received the packet, but how do you know that the packet content is right, is not corrupted?
You have OSI, you have 7 layers, right? And OSI standard, you have 7 layers, and UDP is in the 4th layer.
Yeah.
And the CRC actually will be lower than the 4th layer. For example, physically, the physical layer, they would do the CRC check. And if you want to, I guess the layer 2 might have some kinds of, you know, error detecting mechanism. So you don't need to worry about. This is a high level.
Okay.
Yeah. So, okay, let's try